if there aren't any questions, I guess I'll continue immediately to the hypothesis testing. We did this last week, but I will try to go into detail of each case in order for you to get a better idea. So I'm going to go through some of the scenarios, shall we say, that you may encounter, and we'll try some together. So first, the argument is why we need to do hypothesis testing, because the previous two materials, if you submitted your exercises of last week, the previous two chapters ask you to actually give me the value of the parameter. So they ask you to, hey, estimate what's the mean, what's the variance, and so forth. But sometimes you take samples from the population not to get an exact value of the parameters in the population, but you want to learn something about the sample to conclude a hypothesis, an assumption, a claim, a prediction. No, sorry, that's the wrong word. A preconceived notion that you have about the population. Like, for example, I think that UI students have a GPA over 3.1. So this is a preconceived notion that I had about UI students, but I need to validate it, but there's no way I can study every single UI student. So let's just take 10 people out of the international class, for example. Of course, that's not a good sample because it's not randomized, but you get the idea. So this conjecture or this assumption or this preconceived notion can be about any parameter. So in order for me to validate my conjecture or my assumption or my, what's this? What is the correct correlate, the correct English word to dugaan? Okay, you guys get the idea, but does anyone have it? Assumptions? Yeah, I already used that assumption. I already used that word, but I don't think dugaan translates directly to assumptions, right? But you get what I mean. So in order for me to do that, I have to do something called hypothesis testing. And obviously this is an academic class, so we are going to use an academic method in order for us to do that. Okay, so these are the steps that we need to follow in order for us to be able to validate or to reject or accept the hypothesis. 1, 2, 3, 4, and 5. Do you guys remember each step? Don't worry, I've put it together here. First is state the hypothesis. 2 is set the criterion. And 3 is compute the test statistic. 4 is construct CI, confidence interval of parameter. And 5, interpret the results. Note that I intentionally grayed out the step 4, construct CI of parameter. So you don't need to do this step for you to conclude your hypothesis. I also I don't know why this the reference that we're using requires this as a step, but I don't think it's that necessary for the hypothesis testing itself. Thus, I'd like you guys to remember that when you need to solve a problem about hypothesis testing, step 4 will be optional, meaning that if you do not do it, you will not get points cut off, taken off. The full score of a problem will be for steps 1, 2, 3, and 5. But if you do complete the confidence interval, then I'll count that as bonus points. I hope that's clear. And plus, there's also one more thing, that when you're computing the test statistic, we know that we can use z-scores if we know the variance or the standard deviation. But if you don't know it, you should use the t-score. But we also learned that in previous chapters that when I have a very big sample size, we can use the z-score. I remember that the number was around 30. So if you have a sample size larger than 30, you can use the z-score. But I would like to put a star there. since this is in this class, you will almost always be given the Z table and the T table, then let's not use this last scenario. Please use the Z-score for unknown variances only if the T-score is not available to you. So if you do not have the T-scores, then it's okay for you to approximate it using the Z-scores, but let's focus on the first two for the purposes of this class. Okay, and from the scenarios that we covered last week, we have these 4 scenarios. So this sample, the sample is either obtained from one normal population, and we can have these various H nulls when the variance is known and unknown. And second is if the sample is obtained from 2 normal populations. So we can have these H nulls when the variances are known or when the variances are unknown but equal. So from these 4 different ones, we need to compute the test statistics differently. So this is the first scenario. We have H null, H1, and so forth. This is when it's unknown. We have H null, H1, and so forth. This is when we have two normal populations, and this is and the known variances. And this is when we have the unknown variances. So I would like to remind you to please re-download the slides. I have uploaded the newer versions on Skele because it has been brought to my attention that there were some typos. For example, in this one, I had the variances here instead of 1 because obviously when I made my slides, I copied them from the previous slide and I forgot to change them. Apologies, as well as some equalities that were missing. So please download the newest version that was updated this morning for these small corrections and the correct formulas. So I'm going to present to you a couple of exercises that I'd like to do together. But before we start, I'd like to invite you to ask any questions that may have come up during the review. And while we're at it, maybe 3-minute break so everyone can get their drinks or maybe some pen and paper to follow along with the exercises. So I'll see you in around 3 minutes to start the exercise, and I'll wait if there are any questions in the chat box. No questions yet? There's 1 more minute on my clock for the break.
Actually, I have a question regarding the last exercise. Is that okay?
Okay, you surprised me, but yes, go ahead.
For the number one, based on the what is it called? The sample you given in a video, somewhere I forgot what it is. The for number one, it is the
Wait,
sample mean is
the
between
sample number one or the
the
exercise number
sample
one?
mean, the
No, no,
exercise
no.
number one.
The on my video, so it's what I did together with you, or the one that you
I
have on your
believe so.
video?
So yeah, yeah.
Okay, okay.
For number one, it is given the sample mean between from one to another sample mean, but in the number one exercise 12 or 13, it is not given how to do the exercise number one.
Okay, wait a minute. So number on the sample that I gave you, like through the video, what was given? Sorry, one more time, Jerome.
Okay, let me check it first.
Hey, you don't remember it. So what was not given? Let me check it too.
I remember the example was the what is it called, statistic on the internet.
Oh, okay. Oh, okay. My bad. On the order that I presented is not the same order that I have on my cheat sheet. So where are we? Wait, on the example, I think number one did
No,
not have.
the exercise week 12 and 13, miss, like
Oh, so the one that
the
you
last
did, you
exercise we
needed
did.
to do on your own, right? Is that correct? The one that you needed to follow, that you needed to submit on your own. Is that correct? Did he just freeze?
I did, I
Oh,
guess.
okay. It's the one that you needed to do on your own, right?
Yes.
Yeah. Oh, okay. So this actually was already presented in class. That is why I didn't do it in the video. So in class, I believe, what was the sample that I used in class? I don't even remember, sorry. But in class, I think I showed like statistics on the internet as well, right? So
Yes.
the range in which you need to compute the probability is, you can define it on your own. You can define it on your own. So like, let's see if it is correct that the average amount of night sleep for my sample. So in this case, it was 6.8, right? So you can maybe define maybe 5 to 8, for example. The important thing is that the population mean is contained in the range that you define. And you know that the larger you make the interval, the higher your probability will get, but it will be less accurate. So yeah, you can do it longer. Then you can, for example, I want to check if it's between 1 and 10 hours. So you will probably get a high probability, but it doesn't really make sense for you to compute the average between 1 to 10. So perhaps in this case, it would be most accurate to use, I don't know, 5 to 8, maybe. So
I
yeah,
used 5 to 10, but I
oh,
got the z-score 4.7, which doesn't really appear on the z table
yeah, it doesn't.
given.
Okay, so in that case, then you should use a different range. That's it.
Okay, next time
Okay.
maybe.
Yes. Yeah. Don't worry.
Thank you, man.
Don't worry. Yep. Okay. Bagus turned on his camera. Hello. Thank you. Did you have a question, or you're just keeping company for Jerome?
Actually, I already did.
from the start, actually.
Oh, really? Oh, thank you,
Yeah.
Agus. Okay, I didn't notice you until now. Okay, 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 guys. I didn't notice. You guys can leave them on. It's okay. I like the company. So if you guys want to leave it on, be my guest. Okay. Any other questions, guys? Oh, next week, a lot of you will have to turn on your cameras for the presentation. I'm excited to see a lot of your faces next week. But any other questions? Okay. So if not, let me share my screen once more. Okay, so here is, I have prepared a couple of exercises. I will not cover every single scenario, but these are maybe a couple of samples in which we can both read the problems and try to translate it and solve the hypothesis. So here is the first one. I'll give you some time to read it through. Okay, so let's try to do this one together first. So let's see what information we already have here. I'm not muted, right? No, I'm not. Okay. So this researcher claims that the average price is less than $80. This is his claim. So he claims that the mu of this running shoes is less than 80. He then chooses a sample, a random sample of 36 running shoes. So this is our sample size, N, and finds that the average price in the sample is $75. So this is our sample mean, not population mean, but our sample mean. We assume that the price of the population of running shoes is normally distributed with a variance of this variance. We know that this is the variance. Is the researcher's initial claim valid with a level of significance of 0.1? So this is our alpha, our level of significance. So how many populations are we talking about here? One or two? What is our population? Bagu says one. Yes. What is the population? Not people in this case, right? What's our population here? What was sampled for him? Exactly. Price of running shoes. And that's actually the most accurate answer, because a lot of people would answer running shoes is the population, but it's not the running shoes themselves. It's the price of the running shoes. Okay, so now all of these points that we know is we have N, we have X bar, we have the claim, we have the variance of the population, and we also have the level of significance. We also know that we have one population, and the variance is most obviously known, right? This is no. So with all of this information that we have, oops, sorry, this is a typo. This should be N. Apologies. Other than that, I think it's correct. So these are all of the points that we know. We know that the guy is claiming, the researcher claims that the mu should be less than 80. And then, and next, the N, we have the sample size 36, we have the X bar, we have the variance of the sample, and we have the alpha. Oops, my bad. I think this is supposed to be variance, right? This is supposed to be variance, perhaps. Then we also know that it's one population, and we know that the variance is known, and we also know that it is a one-tailed test, directional, because it's not equal to or not equal to, but it is less than. And in order for us to compute it, I have copied here the steps that we need to compute, but the one that is in particular to our, what we want to know is which one? We'll go through that next. So we're going to go through the steps that you need to compute. Note that I have left out step 4 on purpose for the all intents and purposes of this exercise, but you can compute it using the same methods that you did in the last chapter. So remember that for the hypothesis is usually what we want to disprove. Remember that we've already mentioned usually what we want to disprove. And also the H0 usually consists of an equality. That's one hint that you can look for. And thus, in this case, the guy claims that this is the mu, the average price, is less than 80. So for our H null, we can define that what we want to disprove is that the mu, the opposite of it, is larger and equal to 80, while the alternate hypothesis is that the mu is less than 80. And this is the researcher's claim. That's why here I've only copied this section of H null this way and H1 as follows. Next, set the criterion for rejecting H null. So we already know that our alpha is 0.1. And we also know that we know the variance. So in this case, we need to follow this rule. Reject. So our criteria is we will reject H null if the test statistic is less than minus Z alpha. Okay. Next. Oops, sorry guys. And next, we need to compute the test statistic. So here, let's compute our test statistic. This is the test statistic that we need to compute. This is the square root of n. Our n is 36, I think, yes. This is right, yes. Minus X bar is 75 minus our mu0 divided by our sigma. So here what we are given is 368.84, right? So here it is the square root of 368.84. I think it should be as follows. Okay, anyone? Anyone have a calculator ready? I have the cheat sheet here, I think, but for some reason, I don't think it's correct. TS, X bar, anyone, please? Saddam said calculating, so there's a loading screen on the calculation. I have various calculations. I have negative 1.56 and blah and blah. Okay, as usual, usually in our exams, you might have noticed that I usually ask for 4 digits of precision. So let's just be consistent and we'll do that. So it is around minus 1.56 to 1, I think, yeah, if we want to round it up. Okay, so let's interpret the results. We want to reject H null if our test statistic to 1 is less than minus Z alpha. So this Z alpha is the opposite of, wait a minute. It's not what you look up, right? It's the opposite. Remember when you have the notation Z alpha, it's the opposite of your lookup table. So in, oops. So in our case, it is, we need to find the correct Z value here on this end that corresponds to a probability of 0.01 because, wait, 0.1 because our alpha is 1%, right? Yes. So 10%, apologies. So here, our alpha is 0.1. So this corresponds to a probability of 0.1 or a confidence of 90%. So if I go back to our z-score table, I want to find the probability of 0.1 exactly. And if you go through these values, the closest you can get to 0.1 is this value here. This is the closest value you can get, and it corresponds to minus 1.28. 1.28. So thus, our Z alpha in this case is minus 1.28. So here we need to check, is our TS less than this? And you can see that it is negative 1.5621 is indeed less than negative 1.2828. Thus, we can reject H null. And if I reject H null, then I can assume that H1 is correct. Thus, the researchers' claim is valid. Is valid, is believable. We have enough evidence to support the claim. All of these are just different ways to mention that the H null is rejected. So just now when we were looking through the table, you might have gotten a little bit worried that, oh my God, we have to look it up the opposite way, right? But actually, you will probably only need to handle alpha values of 0.1 and 0.05. So a lot of the time, those values will be already given to you. As proof, I'm going to show you a snippet of last year's final. Where are we? I'm going to show you a snippet of last week's, maybe not every single part of it, in case I want to reuse these. Let me scroll through it yet. Here we go. Here we go. So in last year's finals, notice here that you will be given these values because the common values are the same. And I do believe that I also gave the t values. Yes. So don't worry that actually the values that you will have to handle are itu aja. So it might be in your best interest to remember the alphas of 0.5, 0.25, 0.1, and as well as the t alphas of t 0.5 and so forth. Okay, let's go back to the exercises. Any questions? I'll give you around maybe 2-3 minutes to maybe write some notes down or read through the example. If you have any questions, feel free. Okay, so in this example that we have just covered, this is the example of one population and the variance is known. Obviously, if it's still one population, but the variance is not known, it's going to be more or less the same, but you need to use the T table instead of the Z table. I'll show you briefly the previous table that we used. It's this one. But if you do not know the variance, you would change your test statistic as follows, as well as you need to use the lookup table is your T values instead of your Z values. That is literally the only difference between the two, which is why I'm not going to do that together. And we're just going to go on to a two population example. Oh God, wall of text, wall of text. Don't be so scared yet. I'll give you around 3 to 4 minutes to read through it. And then we'll do the translation together, just like we did for the previous exercise. Okay, so I've already started to give you some hints of some important information. Now it's your job to think about what is the 10 here? What is the 12? And obviously we're given raw data here, so we need to compute some things on the left-hand side. So one student once asked me, what about the finals? Is the material from midterm only or before midterm? So as you can see, I don't think I will need to explicitly ask anything about material before the midterm, because here you will still need to be able to compute basic mean and basic variance for a lot of the advanced material. Okay, so I'll give you some time to get a head start maybe. First, oops, sorry. So we have obviously here two populations, right? The first populations are people that got the vitamin C tablets. And the second group or the second population is people with that were given the placebo tablets. And here you need to determine what is your first group and what is your second, just simply because the X is minus Y, and that will affect the order of your hypothesis testing. But, of your initial hypothesis null and your hypothesis, alternate hypothesis. So I'm just going to use what is written on the screen. So I'm going to use the left-hand side is my first population and the right-hand side is my second population. So in this case, vitamin C is the first one and the second one is placebo. So here, when I say a random selection of 10 volunteers were given vitamin C's, I'm then going to use N to annotate that, and this is M. It's the number of sample size for my first population and my second population. So here, I have already computed this beforehand. I hope we don't need to remember or recall how to compute averages, but I'm going to ask you to please compute the averages for me, but for the variances, I'll just give them to you that were pre-computed. 581, this is 0.778. And I'm gonna ask you, just to make sure you guys are not dozing off, to compute the averages of each population. Please let me know when you have computed them. Okay, thank you, Kevin and Saddam. I have the same answer from both of you, so I think you guys must be correct. So the average for this one, oh, no, why is my pen not coming up? So here it's 6.45. Can't read that, let's redo that. 6.45, and this one is 7.125. Great. So let's put together our information, but there's one more thing before that we need to translate. So what is the hypothesis here? So what we want to know is, does taking the vitamin C reduce the mean length of the cold? So here, notice that what's this information that we know? This is the length of cold, right? So our population here is the length of cold. Note that just like previously, it's price of shoe and not the shoes in themselves. Here, it's not the people themselves, but the length of their colds. So this is the length. I want to know, this is the average of the sample, but in the population, is this mean, the mean of people taking vitamin C, and this mean, people that are taking placebo, I want to know if it is correct that this is less or equal to the placebo. So does this data prove that the vitamin C actually does something to reduce the mean length of the cold? So putting together all of this information, so we have this test. Our test is the 4 grams, but the patients are given. Sorry, Bagus, what's up? Sorry, 1 gram and 4 grams. Did I type it wrong? Oh, I think it's just simply that its tablets are 4 times a day, right? So in total, you get 4 grams of vitamin C. I don't think that's a factor because here it says 1 gram of vitamin C taken 4 times a day, taking 4 grams daily. So yes. Okay, so be careful. There are some trickeries in the question, so that is not really relevant in this case. So here we have that information on top. We have the averages, the sample means, as well as the sample variances. We have the sample size for the first one and the second population. We next also have a test in the sense that we need to know what's the difference between the mean length of colds for people who drink vitamin C and the mean length of sickness or colds for the people that drink the placebo. And here we have 2 populations, obviously, but we do not know the population variance. But since there's no other scenario that we know, we can just assume that the variance of each population is equal. Note that you are not given a level of significance here, but I think I've already mentioned that if not explicitly mentioned, just assume that the alpha is 0.05 or 0.1. This is the common numbers used. I personally usually go to 0.05 first, but it's not wrong if you do it 0.1 as long as you note down in your answer which level of significance you use. So since this is the case that we need to handle, I screenshotted the computations that we need to do. We do not know the variances, so we need to use our T table here. And then we need to compute these steps. So that's what we're going to do together. Obviously, I could not move the entire all of the information from the previous slide. So I couldn't put it on this one, but let's try to do it together. So what is our hypothesis? So, oops, guys, sorry. I just realized that this is wrong. Shouldn't be equal because it says less than, right? Reduces the mean length. So it should be less. Sorry. Okay, so from our hypothesis, we want to know between the mu of people taking vitamin C and the mu of people taking placebo, is it correct that the mean of those given, given vitamin C, is it correct that it's less than the placebo? Just like the previous question, this is the claim, right? So what we want to refute is the opposite. So RH0 will say, what's the, RH0, sorry, will say the mu of C is obviously the opposite, larger or equal than the mu of placebo, while our claim or our H1 is the opposite, is the people drinking vitamin C having a less amount of cold, less time having a cold than the people having a placebo. This is our claim. Next, set the criterion for rejecting H0. We know that the alpha is not given. I am going to assume a value of alpha of 0.05. It won't be wrong if you assume alpha of 0.1, but in this example, I'm going to choose to use the one that I prefer, 0.05. This is a safe alpha because it's the limit that is usually recommended is at 95%. It's the highest confidence that you should be confident taking. So here we need to use the T score. And don't forget that when you are computing the T, not only do you need to bring your alpha information, you also need to bring the information of your data points. How many data points do you have in this case? So here we have, was it 20 or how many do we have? data points? We have 22, right? Yeah, we have 22 points here. Yeah. So here for our t, we have the t of alpha and 22, which you will be given this using a t table. So let's go through it just once. And I'm going to go looking for my t table while you guys can go ahead and continue the computation of the test statistic while I find the t table. So go ahead. I'll leave this up on the screen. Hi, Bagus. Yes, you're correct. I going through the slides, I just realized that that's why it's not a good idea if I don't copy the equation to the next slide. So it should be 20. Can you explain why, Bagus, to your friends? Not 22. You can unmute yourself, Bagus. Don't worry. Well, don't worry about it, but you can refer to our rules of rejecting H null. I'll leave that as a small trivia for you guys. Why does it have to be -2? But anyway, the second parameter that we need to bring before we look up the t scores is the degrees of freedom, which usually corresponds to the number of samples, usually. But since here we're talking about two populations, we use the number of degrees of freedom is the sample size of both -2. And thus we have 22 here, but the lookup value is not 22, but 20. Let's do this. 0.05, 20. So I'm going to, I already found my t table. Where is it? T table. That's not right. T table. Okay. So here's my t table. I need to find 0.05 and 20. So 0.05 is here and 20 is here. 2.845. So let's go back to our slides. Why does my key, okay guys, help me figure this out. My answer key says this is equal to 1.725. But just now we looked up the table and it's not that value. Does anyone have any idea why it's wrong? I looked at the wrong table, the wrong column, didn't I?
It should be 0.05 instead of 0.005.
Yes, thank you very much for your correction. I looked at the wrong column. Thanks. So 0.05 and 20, that means it's this one, right? Okay, 1.725. Alpha is this, yes, and the degrees of freedom is that, then it's 1.725. Thank you. Whoever that was that answered, that helped me out. I'm sorry I did not see who it was because you didn't show your face. I hope you don't mind. I don't remember your name. I didn't see your name, sorry. So we have 0.05 and 20. It was Bagus, really?
Yeah.
That was a different voice, Bagus. I did not recognize that voice. Okay. So it's 1.725, that's our rejection. And if we look back that's our rejection region, sorry. And we look back in this rule, we have, what's our hypothesis? Our hypothesis is the H null is, the first population is larger and equal. So here our first population is larger and equal. So this is the rule that we need to take. So I will need to reject H null, sorry, if the test statistic is less than. So I will reject H null if my test statistic is, I already don't remember, less than 1.725. Now we can compute the test statistic. Okay, guys, this is where it gets kind of complex. I'm just gonna do this for you. Wait a second. Haha, you figured out my method. Okay, here we go. I hope you guys can see this on your screen. If we were doing an offline class, you probably wouldn't be able to see this on the projector, but thankfully you guys have your own personal screens here, so I hope you can read them. So we need to compute first the SP and so forth. I have already computed it. So based on my computations, this part, the bottom part is, this is SP2, or the population, the estimated population variance is 0.689, and thus the test statistic, it is 6.45 minus 7.125 divided by 0.689 times 1/10 plus 1/, no, not 20, oops, 12, 1/12, and it should be equal to, based on my pre-computed values, minus 1.90. Okay, I'm gonna give you guys around 2 minutes. Is that enough? Maybe more, to correct me in case my computations were wrong. Anyone? Did I compute it right? Or you're not gonna bother to check? Assuming that I computed it right, then, wait a minute here. My interpretation has to be based on my rejection region. Oops, somebody chatted me. Did I do it wrong? Oh, Bagus got minus 2.288. Anyone else? I might have gotten it wrong. Anyone? Anyone? Help, help. Let me recompute it then. Johannes also got minus 2.28. Saddam got minus 0.89. 0.89. Okay, let's do it together. I'm going to make a whole different slide just for that. Don't worry, Saddam said he messed up. Hey, I messed up too, and I'm the one that's supposed to be teaching you guys, so don't worry. Let's try this. Okay, let's do it. Oh, if everyone if everyone agrees, does that mean that I can take it as correct and just think that you guys will just forgive me for making a mistake? Did you by any chance compute the SP squared? Any of you? Do you have the answer here? Anyone? No? So you did it like immediately, like from the beginning to the end? Oh, okay. Okay, so I'm going to assume you guys are right. We can check it later. I'm also wondering why I computed it wrong. Where is my eraser? Can I not erase this? I cannot erase this. Okay, so let's just assume I'm gonna cross out my own answer. And we're just gonna use the consensus of the class, okay? So it is, what did you say, minus 2.28, is that correct? Did I remember right? 2.28, yes. 2.28. I would like to be consistent, usually using an accurate precision of 5. So let's follow 2880. 2880. Okay, so our interpretation here is we need to reject H null if the test statistic is less than 1.725. Oh, sorry, minus 1.725, right? So the TS must be less than minus 1.725. So here it is minus 2288. No, 0 less than 1.725, which is correct. And thus we can reject H null, or in the other hand, there is sufficient evidence to back up the claim that the vitamin C will reduce the duration of the cold. Yeah. Thankfully, even if I had 1 minus 1.9, I would still come to the final conclusion. So you guys might have noticed that there was a lot of room for error in this particular equation because of all of the tedious computations that you need to do, starting from a simple computation of computing the means and computing the variances, and then computing the SP and the test statistics, looking up the T. Remember that the second degree of freedom, the second parameter of degree of freedom is not simply the number of samples, but you need to minus it by 2. There are a lot of small steps that can trip you up in these cases. So be careful. I have already messed up just now too. I'm gonna check that right now. Why is my key wrong? But anyway, what I want to emphasize here is this is why I hope you will compute your statistics like X bar and variances manually, in the sense use a calculator and don't use a Excel formula, for example, because for some reason the standard deviation of Excel is usually not accurate. So maybe don't use that. I've noticed that sometimes it's not the same values. So I recommend you to use a simple calculator to aid your computations. Okay. Any other questions? Matplotlib from Python. I think it should be accurate, although I also do not recommend that for computing basic statistics in this case. And everyone has a collective sigh. Oh, damn it. Okay, any other questions? Okay, so if not, I'm going to present to you one last example. If you don't know what to do with it, don't worry, but please try to extract what information you can from the description. Okay, any information that you can infer from this description? Okay, in this class, which of you got topic B for your group assignment? Topic B, B. Ooh, not R, B. Anyone? This probably looks familiar. So there's actually one more type of population aside from the 4 scenarios that we looked at here. There is actually one more. If you remember from our parameter estimation, there is actually one more type of population that we handled. It was the Bernoulli case. I don't know if you guys remember. You should remember. But this is the exact same type of setups or scenarios that were covered in parameter estimation about the 1 normal population and the 2 normal populations. But in the previous chapter, we also handled one more case, which was the Bernoulli population. So in this setup, in this scenario, we actually have more of that of the Bernoulli population due to the indicator variables here. So here it's either yes or no, right? The males either prefer bikun or not. The female students either prefer to use the bikun or not. So in this case, I would like to present to you one method of solving it. So those, especially for you guys that have a topic B, you might notice that it's modeled in the same way. So because it wasn't covered in class, I was expecting you to either use a normal approximation, because remember, you can approximate a Bernoulli variable using normal. I hope you remember that. You can estimate the Bernoulli population or the Bernoulli random variable using the normal. So if you prefer, you can model the problem using a normal approximation. That would be perfectly fine. But it's also been brought to my attention from the assistants that there is an alternative method found by the mighty Google. And when I was reading through the references referred in this particular link, I found them to be quite valid. So I decide to present this to the class as well. And you can see it here. Sorry, give me a minute. Here. So up there on the top is the full reference that you guys can use, especially to you guys that have topic B. I urge you to read through it just like what I just did recently. And you can note that here, since we're talking about a Bernoulli population, it's either yes or no. You can compute the probabilities of each case. And using that, you can you can approximate the test statistic of a normal variable using the following, using the following test statistic. So you might notice that it looks very similar to the ones that we used between 2 normal populations. It's because it's the exact same one, but this is how you can approximate the same components of that equation using the Bernoulli parameters. So I will be updating your slides with this scenario, and I will re-upload it after this class to Skele. So you guys, especially those that have type B, topic B, can see this sample of computing the binomial slash Bernoulli distributions. Any questions? Oh, note that we use the z-score here, just like what I said, because we are approximating the binomial population using normal criterias. Any questions? Any questions about the presentations next week? Maybe not about material, but anything about the presentations next week? Like maybe how many slides do you need to make and so forth? My answer is I don't care how many slides you have as long as you don't go over the time limit.
Okay, I actually have a question. So
Go ahead.
Okay, so for the slides.
Wait a minute.
Okay.
Bagus is speaking, right?
Yeah.
But for some reason on my screen, Faras is being highlighted. So that was the source of my confusion before. Okay, go ahead, Bagus.
Okay, so for the slides, so do we just, include the recaps, or do we have to go over our research and everything?
Oh, up to you.
Okay, so as long as it doesn't exceed the time limit, right?
Yes. So I don't expect for you to show any raw data. So that's for sure. I don't expect to see any raw data, but maybe you can structure it as a research. So your introduction, for example, should what are you trying to study? What data do you have? What's the basis of it? What is your population, for example? And then you should have completed various descriptive analysis. So maybe a lot of graphs and tables so we can see the proportions. And then finally ending with your hypothesis testing.
Okay, thank you, Ms.
And maybe I'm more interested in the conclusions, maybe that what you guys concluded on your own.
So the conclusion, so maybe for example, is the hypothesis wrong or right? Is it one of the conclusion?
Yes, that is the one that you must include, right? Because you have to conclude if your hypothesis is correct. But I don't know, a lot of the times in these types of, statistical exercises, you actually find a lot of interesting things. Like, for example, maybe it wasn't asked of you, but then you notice, for example, last year, we realized that those that stayed in kos-kosan compared to staying with their parents actually slept longer than those that were living with their parents. Those that were with their parents actually ate less and so forth. Things that you wouldn't expect. If you have found any interesting points, you can bring them up. That's up to you.
Okay, thank you, Miss.
Anything else? Okay, so if not, then I guess I'll see you guys next week. Maybe put on a shirt other than your pajamas because you're going to have to turn on your cameras next week, at least those that are presenting. Don't forget that at the end of each presentation, there will be a mini oral test, you can say, because every single member will be asked at least one question. And there is an opponent, right, from another group that is supposed to ask you a question. I think it's already published on Skele, the groups and their opponents. And if the opponent doesn't ask, then that it doesn't ask a question, that's a deduction of points from the opponent and not from you. Why is Jerome shocked? Why is Jerome shocked? I don't know why Jerome is shocked. I think I've already explained about the opponent system there though. And don't worry, I will not conduct it very formally, but I do expect you to not be laying down in your beds. And simply because you guys will make me want to go lay down in my bed. What's kind of scary, Sada? I don't think I'm very scary. No.
Okay,
No,
Miss,
no, no.
so I'm gonna ask one more question. So what
Sure.
will the question be like actually? What kind of question would you ask personally?
I have to see the presentation first. I don't know.
I can't think of even a single question, even like it is a statistic, right? So the data is accurate. So
Yeah, it
I don't
should
know.
be, yes.
I don't know what kind of question that I should
Like,
ask.
for example, if you showed me a table, like for example, or a graph. Let me find an example here from last year. Let me find a table. This is not a good example. Wait a sec. Downloads. Is this a good one? Like for example here, maybe I'll show you guys this one. Like maybe you presented this and I would ask, Jerome, give me a narration of this graph. Like what can you conclude from this graph? And what I expect is maybe Jerome can tell me, so apparently most students tend to buy food from outside instead of cooking on their own. Or for example, apparently there are still some students that does their own cooking and so forth. Like what conclusions can you take from this table, for example? Sorry, this graph, for example. Give me 3 conclusions you can take from this graph. And for the hypothesis testing, for example, I could ask like, what other hypotheses do you think you could try to prove using the data you have? For example. Don't worry, there won't be any like mutlak, this answer is correct questions. I don't think. That's not the point of what I'm trying to do with the presentation. Any other questions? Okay, so if there aren't any more questions, there is a special activity at the end of this class. You might have noticed that on Scale, there is an assignment slot. So in this assignment slot, you have to submit your answers by 4 p.m. today. I was going to do 3:30, but then I realized that that was really mean because we're only stopping at 3:15 today. It's not a lot of questions. It's only 3, just like the ones that we covered today. So I don't expect you to need more than 45 minutes. We used about 45 minutes for these 3 questions as well. So I do not want to release the questions via Scale because it is going to be special for you guys that are in class today. So please don't share it to any of your friends that are not here in class either. I'm going to send it through the chat right now. I have to find the file first. Give me a sec. Exercise. Okay, here you go. It's sent through chat and you guys can submit it by 4 p.m. today. After submitting this exercise to Scale, you can access the linear regression slides, and I will also be taking attendance from the submission of this exercise. There will not be any more exercises released for this week's activity, only this one, because presumably you need to do your report. So Okay, are there any more questions? Nope, no more questions. Okay, then if there aren't any more questions, I'll leave you to your exercise. Oh, you can complete it in any way you want. You can type it if you want. You can also write it using a digital pen. You can write your answers on paper, take a picture as usual, like we usually do, and submit it to Scale. You don't need to use any type of format because on Scale you have attached to your account, so that'll be sufficient. Okay, if there aren't any questions, I think I'll end the class there and I'll wait for your submissions by 4 p.m. today. Good afternoon.